Hey, what's going on, Lehigh Nation? We're back. We're going to do some more calculus today. Um, we're going to start off with discontinuities. We last talked about limits and we talked about how to evaluate limits that have initially a 0/0 uh, ratio after substitution. So now we're going to talk about continuities. So there are several types of continuities. We've got a jump continuity. Okay, so an example of a jump continuity would be this. You've got a removable continuity, a discontinuity, right? Where you have a, let's see, right here, right, at x equals 0, where if you just fill it in, now there's no more discontinuity. So it's called a removable, right, for that reason. And there's also infinite discontinuity. So if you have like a asymptotic sort of behavior at x equal 3, for example, that would mean that that is an infinite discontinuity. It's like an infinite jump, really. Um, so we just ran through basically number 7 because if we run through it, we've got at a equal -3, right? No discontinuity, great, uh, because you could just flow right through. At a equal -1, you've got a jump, right? At a equal 2, I don't know why it jumps from, it goes from -1 to 2 without going through 0 first. But anyway, at a equal 2, no discontinuity at all. At a equals 0, you've got removable. Okay, and at a equal 3, you've got an infinite discontinuity. All right, so there's that. Number 8. So they give you a piecewise function. Okay, and we've got x plus c if x is less than 2, and the function is a cx squared plus 1 if x is greater than or equal to 2. Now it wants to be continuous at every number. Well, the only real issue, I mean, you've got x plus c, right, to the left of x less than 2. X plus c is a first degree polynomial, right? So it's a linear function. That's going to be continuous everywhere. This guy is a quadratic. This guy's going to be continuous everywhere as well. So the only issue is at 2. So all we have to do is check the condition at 2 to see if it's continuous. Now, now we're not checking any conditions though. We're just going to find the c that makes it continuous at 2. So one of the condition for continuity is that limit as x approaches a, right, of some function equals the function evaluated at a. But for this to be true, the limit has to exist, right? And if the limit has to exist, you need to make sure that the limit as x approaches 2 from the left of f of x equals the limit as x approaches 2 from the right. Okay, now from the left, that's the x plus c function, right? Let me just erase all this just because it's getting messy. The x plus c function is the one I use. So x plus c is a polynomial, so we talked about in previous videos that I could just plug in the x value, so I get 2 plus c. Okay, now for the other guy, I get 2 squared, right? C plus 1. 2 squared is 4, so it's 4c plus 1. The next step, to make sure that the limit exists, is I equate the two, right? So 2 plus c has to equal to 4c plus 1, right? The two-sided limits have to be the same. So, and lo and behold, I'll get my answer, right? So I'll get 3c equals 1. That means that c equals a third, and that's it. Okay, and then you can check that this holds, right? Because if I plug in x equal 2 at a c of a third, I'll plug it into here, right? And that will for sure equal to the limit value. Okay, so now we've got a limit, right, for calculating the slope. This is called first principles, and there are 2 forms of it. Okay, so I'm going to use both forms in a different stage, so in a different question. So so let's see. So we've got number 9. Okay, I'm going to do part A. Let's do it. So the function itself is x squared plus x. So it tells me that the slope equals limit as x approaches a, right, of f of x. But what is f of x? That's this, right? So x squared plus x. So that's the first part. That's this guy, right? And then I got to take off f of a. f of a is basically switch x for a. That's it. So it's going to be a squared plus a. Done. Okay. And then on the bottom, I just do x minus a. Done, done, done. Okay. So the limit as x approaches a, and then I could subtract. I could expand the negative in there. So it's got x squared minus a squared plus x minus a. Okay, double check that. Should be fine. Now notice here, right, at this guy, I've got a difference of squares. So I can break it up really nicely. So I get x plus a, right, a plus b times a minus b. So, whoops. Man, all these letters, eh? It starts to get a little confusing. All right, and so I get x minus a, and then what I can do is I could just cancel this factor of x minus a, right? Because that's giving me the problem due to the limit, right? So I cancel it, make sure I put a 1, cancel it, make sure I put a 1. So in the end, what I will get is I will get x plus a plus 1, right? X plus a on the top plus 1, right? So I get x plus a plus 1, and then I just punch in my a value, right, as a substitute. So I'll just erase this, and I'll put an a right here, and I get 2a plus 1. Done and done. Okay. Now it says find the equation of the tangent line at the given point, and the point is -1 comma 0. So typically x then, or a rather, right, in this case will be -1. Okay, so that means that the slope is going to be -2 plus 1, which equals -1, right? So the slope is -1. And next, what I do is I use these coordinates. Okay, so I go -1, 0, and I call this x1 and y1. Okay, so follow me here. x1, y1, and I have a slope of -1, and I have to construct the equation of the tangent. So why don't we do that? It's very simple, straightforward, and you all remember the slope, right? The slope equation. It's y2 minus y1, the rate of change, y2 minus y1 divided by x2 minus x1, right? Now, we have x1, y1, but where's our x2, y2? That's a good question, right? So we make a point, xy, a general point, right? And you'll see why in a minute. So then my slope equation is y2 minus y1 over x2 minus x1, okay? And so y2 is y, y1 is 0, x2 is x minus -1, okay? And the m was equal to -1, right? Boom. So negative of x plus 1. So I'm basically solving now, right? I'm isolating for my, I'm putting it all together in this form. This is called the standard form of a linear equation, right? Standard form. I'm going to put it in that form. So let's do this. So on the top I get y, on the bottom I get x plus 1, right? I'm going to multiply both sides by x plus 1, and I'm going to get negative of x plus 1 equals y, okay? And then what you usually do for this form, the a has to be positive, okay? So right now, if I expand, the a is going to be negative, right? So I'm going to multiply both sides by -1, which means I change the signs of both, okay? So I end up getting x plus y1 equals -y, and then I bring y to the other side, and I get x plus y plus 1 equals 0, and I've got my equation. That's what they wanted. Okay, so that's the first one. You know what, heck, let's do the other one as well. Let's do, f of x equals x minus 1 divided by x plus 1. That would be fun, right? I hope you're all enjoying this, enjoying the experience with me. So the reason why I post these videos is because I suffered a lot when I was younger. I couldn't really understand what was going on in math, and I had to work intensely hard. I did really well, but I had to work like really hard, many sleepless nights trying to figure out my my math class and physics, actually, because I was a physics buff. I loved physics, so that's why I post these videos, and it helps me feel like I'm giving back. a little bit, and yeah, it's a fun experience, and that's why I do this. It's not, for any money or anything like that, but it's just it's a good experience, and I just love. I just hope to be talking with more of you people, and hope that that those of you that are watching do send me in your questions and stuff, and I could help you out, and yeah, we can grow together in math, right? So okay, f of x is equal to x minus 1 divided by x plus 1, right? So m equals limit as x approaches a of f of x minus f of a. Okay, so f of x is x minus 1 divided by x plus 1. No secret there. F of a is just, again, you switch x with a, so it's a minus 1 divided by a plus 1. Done and done. Okay? And then you've got x minus a in the bottom. Now, typically in these situations, you literally just have to put the numerator. You see, this is a numerator, right? The guy at the top. Numerator, right? That stuff. You have to put this numerator under a common denominator. The common denominator is the lowest common multiple of both bottoms, so you just multiply them together, right? So you get x plus 1 times a plus 1, okay? And then to do this properly, this guy on the left, right, x minus 1 divided by x plus 1, that's missing the factor of a plus 1, so you got to multiply the top and the bottom, so the top gets an a plus 1 as well, okay? Then subtract, and you do the reverse on the other side. So x plus 1 accompanies a minus 1. Now they're best buddies, right? Let me add some more real estate here. Limit as x approaches a. Okay, and then I got to do some FOIL, right? So let's do this. xa plus x. Check this, okay? If you're not too happy with this, check it. Minus xa. Let's see. Plus x. Whoops, hold on. Seems like there's not enough room here. At plus x, right? And then plus a. I see a plus. No, it's a minus a. Minus a. Minus a. Plus 1. And I think that's it. Yeah. Okay, x plus 1. Man, that would have been much easier if I just like, nope, there's should be an x minus a on the bottom there. All over x minus a. Okay. Might have been much easier if I just expanded like legit, right? So, and then put in the sign. But anyway, it's all good. I get minus a and I get plus 1. I think that should be good. And then the minus 1 cancels with the positive 1. Okay, minus xa cancels with positive xa. These guys can accompany my friend x minus a on the bottom. And so I end up getting limit as x approaches a. And I get, look, I get x minus a and x minus a, right? You add them together, you get 2 of those x minus a's, right? All over x plus 1, a plus 1, and x minus a. Okay, x minus a's are gone, okay, and I get 2, right, over x plus 1 times a plus 1. Sub in x equal to a, and I get 2 over a plus 1 squared. Okay, simple as that. Okay, now again, this is my point, and a equals 1, right? So the slope actually equals to 2 over 1 plus 1 squared. 1 plus 1 is 2. 2 squared is 4. 2 over 4 is 1/2. So m turns out to be 1/2. Okay, so that's what I'm going to write. Sorry, I kind of sing songs when I'm like doing my math. I know this is annoying, but bear with me, helping you out here. If you need it. If you're math wizards, then you probably are laughing at my math skills. Who knows? I did some background on me. I did an undergrad degree in physics, and I'm trying to complete my master's in biomedical physics right now. So that's where I'm at, and I don't know if I'm gonna do a PhD. I would love to teach, but that's where I'm at right now. Okay, so m equals a half, right? That's what I got, and my point is 1, 0, and so I get x1, y1. Okay, then I'm going to construct a general point xy, x2, y2, right? And then I'm just going to build my equation. So 1/2 equals y, that's y2, minus y1 over x minus 1. Okay, and then I cross multiply essentially, right? So 2 goes up there, 1 goes down there, or whatever, right? X minus 1 goes up here actually. Okay, and I multiply. And I get, so 2y, right? That's y minus 0 is y. So 2y equals x minus 1. The x is already positive, right? It already has a positive coefficient. So I just bring that over to the other side, and I get x minus 2y minus 1 equals 0. And that's my equation. Done and done. Okay? Not too shabby, right? And you're all happy. Yes? No? Maybe so? Okay. But yeah, that's how you do these equations of the tangents, right? Now, had we been asked to just compute the derivative, it probably would have been easier. What's annoying in these is you have to use the first principles equation, right? This crazy limit stuff, which is annoying, but that is the definition of the derivative, so whatever, right? You got to do it. Okay, so now let's move on to the next form, right? We've got this, it's the same thing essentially, right? So this is the limit equation, first principles, and we're on 10, so I'm gonna write 10 here, right? 10. And so we've got f of x equals x squared. Okay, and this is way too easy. Okay, so we've got m equals f of a plus h. This is where students get a little scared, right? Listen, it's saying take an input, right, x, and just square the input. Here, the input is a plus h, so square a plus h. And so f of a plus h should just be a plus h all squared, right? So what should f of a be? That's right, a squared, right? Easy as pie, okay? Easy as 3.1416, blah, blah, blah. Okay, so the limit as h approaches 0 of f of a plus h, that's a plus h squared minus a squared all over h. Guess what's going to happen? I'm going to evaluate this difference of squares, and h is going to cancel with an h on the top. How much you want to bet? You want to bet money? I can't even bet money. I'm LDS. Okay. Anyway, so we've got a plus h plus a. Okay, that's a plus b times a minus b. Okay. Whoa, dude. Right. Okay. Now the a's in the second factor will cancel, and guess what I've got? I've got an h. Right. So that will cancel with this. Dope. Right? Now all I've left with is a plus h plus a. That's all I'm left with. So I can punch in h equals 0. So a plus 0 plus a, that's equal to 2a. Done and done, right? Okay. Sounds good. And it wants it at the general point. So instead of like a specific, point, you've got a general point a f of a. All right? So don't panic. Okay, so let's do this. Oh man, I love to make jokes when I'm doing math because, math isn't, the ideal, like it's not the most obviously fun course you could take. I remember I took a course on sociology and we would literally just sit there while the prof talked, and it was so fun. Like I just loved it. And you hear about stuff that's like seems so applicable, whereas like, finding the equation of the tangent line doesn't seem really applicable to life, right? But yeah, anyway, but I still love math. Love math more than anything. Okay, so we've got a point a f of a, right? We've got x1, we've got y1, and we've got an m of 2a. right? And I'm going to build a general point x2, y2, so then I'm going to build my equation, right? Nothing new here, nothing scary. Okay, 2a equals y minus f of a. Okay, don't freak out on me, right? It just says f of a, x minus a. Okay, yummy, yummy in my tummy. Okay, so then we've got, then multiply, excuse me, man, I'm burping. Oh, that's gross, I'm sorry. Okay, you multiply both sides by x minus a, and so we get 2a x, okay, minus 2a squared. No way, dude, right? Equals y minus f of a. Okay, easy, right? And then this guy, right, I'm assuming a is positive. It may not be positive. Who cares, right? Just leave it as that. There's no obvious negative here, right? So that's all that counts, really. So then bring this stuff over the other side. So we get 2ax minus y, okay, plus, and we've got this constant, which is f of a, right, minus 2a squared. Check it. You should get that equals 0. And that's it, right? That's my equation, right, for the first part, at least part A, right? Yeah, so that's me doing limits with the other form, you know, the first principles form, right? And I actually did some continuity today. I'm so proud of myself. I hope you're proud of me too. I hope you can support us. Please, like, subscribe, like, comment, share, especially if, like, you know, someone who's struggling at all. This isn't the worst stuff that I've seen for calculus and vectors, but we will get there. I know you probably have exams in, like, what, January or so. I know that that's the case in Ontario, but if you're not in Ontario in Canada, then who knows? I'm going to try my best to do as fast as possible, right? Let's do x cubed, the yummy stuff, right? X equals x cubed. I don't know why I said that so weird. Okay, limit for h approaches 0, all right? Now look, it's saying take an input, right, and cube it instead of square it. So what should f of a plus h be? That's right, a plus h cubed, right? You just cube it. So cool, dude, right? Okay, so limit as h approaches 0, so we got a plus h cubed minus f of a. What should f of a be? Come on, Lehigh Nation, right? That's right, a cubed. All right, all over h. Now, we did a difference of squares. What the heck is a difference of cubes? Don't say you don't know. Come on. Okay, a difference of cubes. So let's see, x minus y, x cubed minus y cubed is equal to x minus y, okay? And it's going to be x squared plus xy plus y squared. Dude, no way. Yes way. Absolutely way, right? So let's do this. So we've got limit as h approaches 0. And the first part's going to be a, oh shoot, this is x plus y. So boom. And then this thing is going to be a minus. Done and done. Okay, so no, what am I doing? What am I doing? What am I doing? This is a minus. I just lost myself for a second. I apologize. Okay, so we're here, right? So x serves as a plus h. So a plus h is x, right? Just keep that in mind. So a plus h, that's why I got confused. A plus h is x. I take off y. Y is a, right? Take off y. That's the first factor. That's this guy, right? Next, I got to do, a plus h squared, okay, plus a plus h times y, which is a, okay, plus a squared, okay? Now listen, what students tend to do is they will evaluate, they will FOIL, expand, right? Do not do that. You don't have to do that in this case. You'll see why. A cancels with this A. Yay. And you're left with H, right? Guess what? They kill, right? They cancel, okay? Now, all I have to do is punch in H equals 0 to what's left, right? That's it. So H equals 0 means that that's only A, right? So this thing only has A left. So A squared plus A squared, plus a squared equals 3a squared. Whoa, whoa. Sounds good to me, right? So that's the slope. That is the slope. And yeah. So then we use our equation again. We construct an equation. I'm just going to erase all this stuff because this is messy. And easy as pie, right? Easy, easy, easy. Man, I love seeing like math memes, you know? Like there's this one where the guy was just like, some guy was telling this other guy, I have like 10 times more girlfriends than you. And then the guy's like, I have 0 girlfriends, so you have 0 as well, because 10 times 0 is 0. Anyway, I thought that was funny. If you don't find that funny, I'm sorry, okay? So yeah, we've got m equals 3a squared. All right, our point is a f of a. And so this is x1, y1. All right, so 3a squared equals, again, my y2 is y minus f of a all over x minus a. All right, and then so multiply both sides by x minus a, and I get 3a squared x minus 3a cubed, okay, equals y minus f of a. Yummy in my tummy, right? Okay, and then I bring this junk over to this side, and I get 3a squared x minus y plus f of a, okay, ooh, not f, f of a, right? Not f. Okay, minus 3a cubed equals 0, and I got my magical, that was bad, okay, but I get my magical equation, all right? I'm sorry. So that's that. That's part B. Let's do C. Let's have some fun here, right? After that, right, so my next video is going to be about average rate of change, that's arc, right? And then instantaneous rate of change, which is just the derivative, but anyway. And then we'll be going into velocity and instantaneous average velocity, which is good because I'm a physics major, okay? And then later on we'll do more first principles stuff and whether something's differentiable, and then we'll go into the differentiation rules. I cannot wait until we do vectors, because that's basically what I've, you know, done all my life, right? Like vectors stuff. So that will be like totally fun. And like, I know back in the day, so I mean like, wow, I sound old. Okay, before they had calculus, like regular grade 12 calculus without vectors. They had a separate class called discrete algebra and geometry, which had like vector stuff in it, I think. But now they merged the two into calculus and vectors, which is what I'm tutoring you on right now. So yeah, calculus and vectors, the stuff that I see in calculus and vectors on like dot product, cross product, all that stuff, I saw that in second year. Like second year physics, like legit physics. So what does that tell you, right? Things are changing. Okay, so we've got our slope, okay, limit as h approaches 0. F of a plus h. Okay, listen, so don't freak out. The input is squared, then you take away 2 times the input plus 1 at the end. That's it. So the input is a plus h itself. So you got to put brackets, right? Square a plus h, take away 2 times that input plus 1. Okay? And then this is where it gets annoying, right? You got to put f of a as well, right? So you get a squared minus 2a plus 1, right? All over h, right? So here the input is a itself. That's it. I don't like talking about x itself. Like I say input because it somehow resonates better with students. I don't know. When I FOIL this, I will get a squared plus 2ah plus h squared. Check it, right? It's a pattern, right? It's always like something squared plus 2 times something. That's all it is, right? Minus 2a minus 2h plus 1 minus a squared plus 2a minus 1. Okay, I expanded the negative in there, right? All right. Okay, so then I can cancel, which is like what you'll basically be doing throughout this entire journey with me, right? It's like the art of canceling stuff. That's all it is. Okay. And so I get limit as h approaches 0. Remember, some h will cancel on the top with an h on the bottom. That's essentially what will happen. Now I can pull out a factor of h, right, in the top. So if I pull it out here, there's that, and I pull it out here, there's that, and there's h, right? And so I can kill it, and I get 2a plus h, sub in h equals 0, I get 2a. Done and done, right? Am I missing something? I feel like I'm missing something here. I gotta be missing something because the answer should be 2a minus 2, right? Right here, I'm missing this. Yes, okay, I am missing it. All right, so I missed a factor right here, 2h. So h squared, right? I had h squared. I take out a factor of h. So really, okay, let's do this again just because I'm gonna lose you guys. All right, so okay, probably shouldn't have sped through that step, but let's do it. So again, I have 2ah plus h squared minus 2h all over h, right? Okay, I missed that term originally, right? Okay, so now I take out a factor of h, so that's gone, that's gone, that's gone. Okay, and I get a factor of h, cancel, and then I can sub in h equals 0, and I end up getting 2a minus 2. Now all is right with the world, right? So I get a factor of 2a minus 2. I'll never pretend to be like perfect because I don't think that helps. I don't think it helps students to think that their tutor is perfect or anything like that. We are all, we're not infallible, right? We can make mistakes. I've seen professors make like insane mistakes, professors that have like PhDs. So please don't feel inadequate or anything like that. You guys are family. Lehigh Nation for the win, right? And so yeah, let's erase that, right? So m is equal to 2a minus 2. Okay, again, a f of a. Okay, so I go y minus f of a equals, y minus f of a over x minus a equals 2a minus 2. So x minus a times 2a minus 2. That requires a bit of FOIL. Y minus f of a. Okay. I end up getting 2ax minus 2a squared minus 2x, right? Yep. Plus 2a equals y minus f of a. That's it. Okay. And then there's a common term here, like terms, right? So 2a minus 2 of x. And then I could probably have done that easier though. I should have noted 2a squared. Okay, so that's the constant 2a minus 2a squared, and then bring it over to the other side, right? Bring the y minus f of a over to the other side. So let's put this all together, all of it. Bring the y minus f of a to the other side. I get minus y, okay, plus, and I can collect the constants together, f of a minus 2a squared plus 2a, and that is my answer equals 0. That's what I get. Okay, sounds good? Great. So that was that monstrosity, and now I've got my final question, which is f of x, okay, equals to 1 over x. F of x equals 1 over x. What's your favorite song, people? Leave it in the comment. Favorite song. I'm starting to like this song called Holy. You're holy, holy. Okay, I'm not really much of a singer, so anyway. I've always been a Taylor Swift fan, to be honest with you. I've always loved Taylor Swift. She has been my chick, you know what I mean? Always been a fan. Okay, so 10d, okay, f of x equals 1 over x, all right? So, it's saying take the input and do 1 over that, right? So f of a plus h has to be 1 over a plus h because a plus h is the input. F of a should be 1 over a then. So easy peasy. We just do m equals limit as h approaches 0. Okay, of 1 over a plus h minus 1 over a all over h. Okay, limit. Do you guys think my h's look nasty? I guess they kind of look nasty, right? Okay. Now again, you put it again with these situations. You got to put it all under common denominator. So it's basically the multiple of the two denominators. That's the common denominator. So it's gonna be a times a plus h. Just multiply them together. To do that, then I got to put an a on this side because it's 1 times a, right? That's the missing factor. And on the other side, it's a plus h. Notice I put a bracket because you got to subtract all of a plus h, not just a or not just h, right? And also, this is all over h, right? So what I can do in this case is I could just put the h right next to it like that. That's what I'm going to do. Okay? And when I subtract the bottom, or the top, excuse me, when I actually expand and I subtract, I get a minus h, right? The a's cancel, okay? And I get a negative h in the top, right? Remember, I don't forget about that minus. That's a negative, right? So it's negative h. So when I kill negative h with h, I'm left with negative 1 on the top. Punch in a equals 0, and I get negative 1 over a times a, right? So negative 1 over a squared. What? Okay. As one of my students typically says, booyah, right? Okay. White Utah Mormon girls, right? What can you tell? What can you say, right? So so we have that. Let's see here. Let's erase this. Okay, and here. Man, I love using this graphics tablet. Like, it's amazing. And I'm using a Linux distro. I say Linux. People usually say Linux, but the guy that created it his name was Linus, right? So I go with Linux. So yeah, Linux Gallium OS on my Chromebook, right? So let's see. I got m was equal to negative 1 over a squared, right? So I do y minus f of a, right, all over x minus a equals negative 1 over a squared, right? That's the slope. Okay, and so I just multiply both sides. I can cross multiply actually, and you know what? I'm going to multiply both sides by negative a squared and then multiply both sides by x minus a. That's essentially what I'm going to do. So I get negative a squared here, y minus f of a. Now if I multiply the side right here by negative a squared, hopefully you'll see I'll get 1, right? But then if I multiply by x minus a, I get that, right? So now I have x minus a, okay, equals negative a squared, negative a squared y plus a squared f of a, right? Okay, I just expanded that. And then I got to bring all this stuff to the other side. So I get x plus a squared y, okay, plus bracket a squared f of a minus a equals 0. And I am done. So that is, so we did, just to recap, we did, continuity, right? Really quick continuity. So we identified types of continuity or discontinuities rather. We did an example where you have a piecewise function and we had to find the constant that made it continuous everywhere, right? And the only issue really was at 2. So if you found it to be continuous at 2, if you found the C such that it's continuous at 2, it's got to be continuous at every number, right? And then we did first principles, right? First principles. And then, yeah, so next time, we'll do average rate of change, instantaneous rate of change, average velocity, instantaneous velocity, and more first principles. And then maybe I might go into whether something is differentiable or not. So if you really enjoyed this experience with me, Please like, comment, subscribe, share, right? Whatever you got to do. This is so much fun for me to do this, and I just do it because I love it. And so, if you can support us, that would be amazing, and I would really appreciate that. So, have a good one, Lehigh Nation, and peace